Welcome back, learners. So as I already told in the previous class, we have discussed about designing the column subjected to the biaxial column, biaxially loaded, that is the axial load as well as the eccentricity of the loads in the column, leading to the two kinds of moments. But the design that what we have seen in the previous session was actually the theoretical approach, where we assume the percentage of steel and we carry out the design and we check whether the reinforcement is safe or not. But practically having the design is not an economical condition, because every time you cannot do iterations for each and every column. That's why today let us learn and develop the Excel sheet of the biaxial loaded column, which we usually practically consider this design approach. Okay, so let us see. So here the major what we have done is the two moments which are present in the column, or what we get from the software analysis. So we consider those effects into the single and we make it into a axially loaded column, uniaxially loaded column. We get the percentage of reinforcement and then we check whether that reinforcement is enough for that biaxial loaded column. So let us see according to that. This is the procedure. Okay, so now according to that we have to give the dimensions. So today let us take one square column. Okay, so therefore if I want to develop the Excel sheet, I can go that the first will be, I can bring till here. Okay, the first will be the given data, that is the grade of concrete. Okay, so the grade of concrete. So the grade of concrete, you know, it will be FCK, which will be given in Newton per mm square. And let us take the grade of concrete as now 25 for this problem. So the next you have is the grade of steel, or I can write reinforcement. So that will also be Newton per mm square only, no change. So for this let us take Fe 415, that is 415 Newton per mm square as the grade of steel. Then let us take the dimension of the column along XX direction. I can take dimension of column along XX. Okay, so that will be mm, and let us take the dimension as 500. Similarly, I can write dimension of the column along YY. Okay, so that will be mm again, and let us take that also as 500. Okay, now let us take the axial load on the column. Axial load on the column, I can give it as PU. Okay, so which will be in kilonewton. Okay, which will be in kilonewton, and let us give that as 2000. Now the moment along the XX direction, okay, the moment along XX, so which will be in kilonewton meter. Which will be kilonewton meter. Okay, so let us give that value as 200. Similarly, I can write moment along YY direction. Okay, so that will also be in kilonewton meter, and let us give that value as 120. Okay, the moment along XS, the moment along YY, that is 200, 120. Right, now in the theoretical approach, now from this we used to get the value of MUX1, MUY1. So like that, as we have discussed yesterday, we used to go out the procedure. But definitely this procedure we cannot do, because if you are doing that procedure, we are supposed to assume the percentage of steel. So therefore now what we do, we take up the effect of both these column and we will find out one moment, so that when we have the one moment and one axial load, it becomes it acts as an uniaxial load. Even though we are making it one moment, the effect of both the moments, that is along xx and yy, will be taken into consideration. So therefore the design will save, right? So let us find out the effective moment. I can write it as mu. Effective moment, I can write it as mu, and this I can write it as muy. This I can write it as mux. Okay, yes. So I can find out effective moment. So my effective moment will be, I can write it as the equals bracket, or what I will do is I will just make some alternate arrangements. So I will just cut this, then I will just paste here. Okay, so I can make first mux square. I can make this value. Okay, then let us cut this also here also. Then next you have muy. Okay, now let us make the square root of this. Okay, so let us make the square root of this. Okay, so the square root of this plus this. Okay, yes, so that will be this value. And finally, so my final moment, that is effective moment mu, will be, it will be 1.15 into this value, will give you effective moment as 268.2 kilonewton meter. So which will be in kilonewton meter only. So this will be your effective moment mu, because I have taken the effect of both moment along x and y. Now since you have only one axial load, that is pu, and since you have only one moment, now I can design it as an uniaxially loaded column. Therefore I will give the value pu by fck bd. So before pu by fck bd, I need the value d dash by d. So let us assume the effective cover. Effective cover, I can write d dash, okay, which will be in mm, as I'm going to take it as 50 mm. Okay, so therefore I can find out d dash by capital D. Okay, so d dash by capital D, I can write it, no unit for this, will be equal to this divided by 500. Similarly, I can write d dash by b also. Okay, so d dash by b also, but here both the d dash by d as well as the d dash by b will be same, because I am taking square column. So therefore it will be same. So now since it is a square column, let us take pu by fck bd value. Okay, let us find out pu by fck into b into d, pu by fck b into d. So value I am supposed to find out. So there is no unit, so therefore I can write pu as 2000 into 1000 divided by fck into b into d. I can get 0.32. Then similarly mu by FCK B into D value. Okay, so that will be again, what is now mu? So this is mu into 10 power 6 divided by FCK into B into D into D. Okay. Right. So that will be 0.85, 0.085. Okay, I can make it only to the two numbers, so therefore I can make it to 0.85 or 86. Right. So therefore now from the chart of D dash by D, okay, from the chart of D dash by D and from PU by FCK BD and MU by FCK BD square, okay, now since it acts as an uniaxial loaded column, right, so based on in which direction the column is going to bend, you are supposed to take. If the column is going to bend along the shorter direction, then you take D dash by longer dimension of the column. If the column is going to bend in shorter direction, that is along the shorter direction, then you take D dash by shorter dimension of the column. Okay, so like that you are supposed to do, because when I take one mu and one pu, it is nothing but your uniaxial loaded column. So you have to consider it as an uniaxial loaded column and you have to design it. So we have seen that in uniaxial loaded column, so we will take D dash by shorter dimension if the column is bending along shorter dimension, D dash by longer dimension if the column is bending along the longer dimension. Yes. Now from D dash by D value or D dash by V value, PU by FCK and MU by FCK BD square. So we can get, if I go to the, and if by considering equal reinforcement on all four sides, and by making the rectangular or the square column, and by taking F of Y as 415 grade of steel, if I go to chart 44 of SP16, I can get P by FCK value. Okay, it is P by FCK value. So my P by FCK value from the graph I am going to get it as 0.05. Therefore I can get the percentage of steel. Okay, I can get percentage of steel. I can give it as PT. I can get percentage of steel is equal to this into 25. Okay, so that's into 25, that is 1.25%. So therefore now from that I can get the area of the compression reinforcement, area of compression reinforcement, that is ASC, which will be in mm square. I'm going to get it as PT by 100 into B into D. So that will give you 3125 mm square. So that is the area of the compression reinforcement. Now assume the dia of the reinforcement provided. Okay, diameter of the main reinforcement. Okay, so diameter of the main reinforcement, I can go to insert symbol, okay, so which will be in mm. So I can use 25 mm diameter reinforcement. So therefore I can get area of one reinforcement, again mm square, which will be 3.142 into 25 into 25 divided by 4. So that will be 490. So therefore the number of reinforcements will be equal to, so this divided by 25, which will give you, okay, so the number of reinforcements will be that will be 3125 divided by 490, which will give you 6.3. but you know, whether it is a rectangular column or square column, you are supposed to provide minimum 4 reinforcement. Okay, it is maintained, but you cannot provide 6 or 7, so you go to the 8. So therefore the actual number of rods, okay, so number of rods provided, okay, it will be, I can write it as n, okay, so the number of rods provided will be 8, okay, the number of provided will be 8. So when I provide 8 number of 20 mm diameter, then your area of ASC value changes. Therefore I can write provided compression reinforcement, okay, provided compression reinforcement. Now it will be equal to 3.142 into, okay, so it is 25 into 25 into how many numbers? 8 numbers, okay, so divided by 4. So that will give you 3927.5, which will be in mm square, okay. So that is provided compression reinforcement. Then finally provided percentage of reinforcement, I can write, so that will be in percentage only. That will be is actually, it will be equal to this 3925 into 100 divided by B into D, okay, B into D, okay, so that will be 1.57. so that will be the percentage of reinforcement. So now we have to check whether the reinforcement we have provided is sufficient or not. We are supposed to check the reinforcement what we provided, that is 8 numbers or 1.57%, whether it is provided sufficient or not. In order to do that, now I am supposed to calculate MUX1 value, okay. So in order to calculate MUX1, I need PU by FCK BD and I need P by FCK. So therefore I can make one tabular column as so calculation of MUX1, okay, so that is calculation of the MUX1, right. Now in order to calculate MUX1, I need PU by FCK BD, okay, I need PU by FCK BD value. This PU by FCK BD value will not change, it will be same as that of this one. So therefore I can directly write that PU by FCK value here itself. And even I need for that D dash by D or D dash by B value, okay, so I need D dash by D value or B dash by B value. So again keep it in mind, if I am considering rectangular column, So while finding mu x1 you use d dash by d value, and while finding mu y1 you find out d dash by b value. But since now I am using the rectangle, I can directly write the d dash by d only, or let us do it as same. Okay, so that is d dash by d and b dash by d. So therefore I can directly write this value here. Okay, I can directly write this value 0.1 it will be. Okay, so then after that you want p by fck value, but keep it in mind p by fck value is going to change. Okay, why p by fck value is going to change is, where p by fck we are supposed to consider this provided percentage, so therefore that will be this divided by fck, which will be 25. Okay, so therefore it will be 0.62. okay, you can make it to 2 decimals, 0.63. okay, now from pu by fck bd value and d by d dash value and p by fck value, go to the corresponding chart of SP16. okay, go to the corresponding chart of SP16. So for this problem I am going for chart 44. I can get mu x1 by fck bd square value. So I can get mu x1 by fck into b into d into d into d, mu x1 by fck bd square value. Okay, so that value I am going to get from the chart, which will be equal to 0.1. okay, which will be 0.1. so therefore I can get mu x1 value now. Okay, so that mu x1 value will be in kilonewton meter. Okay, so which will be equal to, so it is 0.1 into fck into b into d into d. Okay, so which will get it in this value, that divided by 1000 in order to convert it to kilonewton meter, which will be 312.5. right, so that will be mu x. Similarly I am supposed to find out the mu y1. okay, yes, so now let us find out mu y1. okay, mu y1. Now in order to find out mu y1, now instead of doing d dash by d, so let us take d dash by b. Here it is not going to affect because it is a square column, so therefore I can write d dash by b only. Okay, then again I need pu by fck value, so no change. Then again p by fck value, also no change. Okay, so again pu by fck. Now actually instead of this, actually to be frank, if it is a rectangular column, then here if I am using pu by fck b into d, means here I am supposed to use pu by fck d into b. okay, d into b actually, so d into b. So therefore I can use the same thing, which will be pu. What is my value of pu? Value of pu into 1000. okay, divided by fck into d into b. okay, so that will be again 0.32, it won't change. okay, so it will be 0.32, but p by fck, as I already told, I am supposed to use the recent value divided by 25. okay, yes, so that will be again, so if I reduce it, it will come to 0.63. Now corresponding chart by d dash by b value, pu by fck db value, p by fck, and corresponding chart here again same. You are supposed to find out mu y1 by fck bd square value. okay, I can copy this, but there will be a small change. I have to make this as y, and I have to make this as d, and I have to make this as b. okay, so mu by fck db square value, so which will be Now I am supposed to get it from the chart, which will be equal to again 0.1 only here. Okay, so therefore finally I am going to get mu y1 value. Okay, so it will be mu y1 and this will be in kilonewton meter. Okay, so therefore that will be equal to, so it will be equal to, so 0.1 into 25 into, so now I have to do d into this. Okay, so divided by, okay, so that will be, and again 312.5. okay, that will be again 312.5. so now I got the calculation of mu x1 and mu y1. so finally I am supposed to verify that. Okay, so I am supposed to verify whether that it will be we have to check now. So what we are supposed to check? So we are supposed to check, so mu x divided by mu x1. Okay, so to the power of alpha n. Okay, so I cannot, let me check whether that alpha is symbol present or not. Yeah, to the power of to the power of alpha n. Okay, to the power of alpha n, right, plus again mu y by mu y1 to the power of alpha n again. To the power of alpha n, it should be, okay, it should be less than or equal to, should be less than or equal to 1, right? Yes, so this is my condition. Now I am supposed to check this condition. Okay, I am supposed to check whether if that is coming less than 1, then whatever the reinforcement that is providing 1.571, that is 8 numbers of 20 mm dia, that is more than sufficient. If not, you have to redesign it. Okay, so now let us check this. So in order to check that, I know the value of mu x, I know the value of mu x1, I know the value of mu y, I know the value of mu y1, but I don't know the value of alpha n. Right, your alpha n actually, if you see this, your alpha n actually depends upon pu by puz. Okay, in that already the value of pu I know, but I don't know the value of puz. As per IS 456 2000 clause 39.6, your puz is given by this value, that is 0.45 FCK into AC. AC represents the area of concrete, plus 0.75 F of I ASC. ASC represents the area of the compression reinforcement. So once you get that puz value, when you do pu by puz, if it values 0.2 means your alpha n is 1, 0.8 means alpha n is 2. If it is between 0.2 and 0.8, you have to do the interpolation and get the value. In case if your pu by puz is less than 0.2, then take alpha n as 1. If pu by puz is greater than 0.8, then take alpha n as 2. Right, according to that, now we are supposed to find out puz. In order to find out puz, as per this equation, we know the FCK value, we know the Fy value, we know that we have to calculate AC and ASC. ASC is nothing but the compression reinforcement that you have provided. Okay, so I can write this itself, that is provided compression reinforcement, ASC. Okay, I can write ASC, which will be in mm square. I can directly write this will be equal to this reinforcement provided. Now I need AC. Okay, what is AC? So AC is actually, it is equals to, okay, it is actually equals to AG, that is gross area of the concrete, minus ASC, okay, which will be in again mm square. So that means I can write what is the gross area of the concrete. I have 500 into 500, okay, that is the gross area of the concrete, minus, if I do the area of compression reinforcement, I get only the area of concrete. So that will be my area of the concrete now, okay, so that will be area of concrete, okay, so that will be area of concrete now, okay, 500 into 500 minus this value, that will give you the area of concrete, okay, yes. So once I get this, now my aim is to calculate PUZ value, which will be in kilonewton again. So what is that PUZ value? I have to make now, first will be 0.45 into FCK into AC I have calculated, minus 0.75 into F of Y. What is F of Y? 415 into ASC. What is ASC? This value, okay. So I can close the bracket and I am supposed to divide by 1000, so that I will get the value of PUZ as 3990 kilonewton, okay. I'm going to get the value as 3990 kilonewton. So this 3990 as the value of this, okay, 3990, which will be in kilonewton. Now once you get this, you find out PU divided by PUZ value, okay, so which will be equal to, what is the value of PU I have? The value of PU is 2000 divided by PUZ is this one, so that will give you 0.5, okay. I can round it off to this, okay, so 0.50. Now from that table, go to this table, it is between 0.2 and 0.8, do the interpolation, get the value of alpha n, okay, so get the value of alpha n. So therefore I can get the value of alpha n, okay, that alpha n as per this it is 1.5, okay, the alpha n is 1.5. So once you get the value of alpha n, find out this value now, find out the value, right. So in order to find out that value, now I need first MUX by MUX1, okay, so MUX by MUX1 to the power 1.5, okay, yes. So let us find out first now MUX by MUX1, okay, yes. So let us find out first MUX by MUX1. So what is MUX? So MUX I have given this divided by what is MUX1, you got this value, so that will be MUX by MUX1, that is 0.64. Then similarly now I need MUX by MUX1 to the power alpha n, right, yes. So to the power alpha n, okay, yes, sorry, yeah, right. So this will be, yes, so that means I'm supposed to find out I'm supposed to find out 0.64 to the power 1.5. okay, so that will give you the value 0.512. okay, similarly find out MUY by MUY1. okay, so copy this. okay, so then copy this. So I need now MUY by MUY1. here again MUY by MUY1. right. So what is your MUY by MUY1 value? MUY by MUY1 is this divided by MUY1. so that will give you this. So now therefore this will be this to the power 1.5 will give you this value. okay, yes. So therefore finally when you find out this value, when you find out this, okay, so that will be equal to, so this plus this, which will be equal to 0.750, which is less than or equal to 1. okay, it is less than, okay, it is less than or equal to 1. So therefore the reinforcement what we have provided is sufficient. Therefore I can write here as that, what I can write, I can write, okay, main compression reinforcement what I can going to provide will be equal to, okay, will be equal to, so I can write directly, I can write, where is that 8 number, yeah, I can write 8, okay, 8 number of 25 mm. okay, I can write 8 number, okay, 8 number of 25 mm diameter, right. So like this I can write this. So finally I can give this. okay, yes. So this is how you are supposed to do the design of the biaxial loaded column in practical manner. So when we are doing this, there will not be any iteration process, and even the section will be economical, because you are going to get the actual percentage of reinforcement required. But if you are assuming and if you are doing that, then it will not be economical, because first we will take 2%. if it is going to be over, if it is going to pass, and if you keep that, so it may be an over reinforced section. So therefore you will go for 1%. when you go for 1%, then the section will fail. Then you will go for 1.5%, okay, then the section will remain safe. But again it may become uneconomical, because 1.2% of steel itself may be sufficient. So therefore you cannot get the economical section, but here you can do economical section and you can get the actual percentage of steel. So in this way we are supposed to do the design of biaxial loaded column. So in the next lectures, let us start the design of doing that structure in the ETABS. Then we will go to the design of beams and slabs. Thank you, learners.